Welcome to a demo of Semantic Brains Analytics Agent. I start this demo by dragging and dropping a file. Once the file is loaded, you can scroll through the data to view all the columns, or you can paginate to view all the entire data set. Below the data set is a summary report that identifies total number of rows as 10,126. There's no missing values. There's no duplicates. There are some outliers. There's customer age outliers. There are two of them, and there's other outliers as well. So I want to investigate these outliers by typing in show customer age outliers. And it identifies people with the age of 70 and 73. To investigate this, I go to the data set and I can sort the customer age column, and I can find there's one person age 73, another age 70, and people 68 and under are not considered outliers. Similarly, I can also ask other queries like how many females are there, and it identifies that there are 5,300 females in this data set. And if I want to view the records of just the female population within this data set, I can filter it by gender female. As you can see, you can easily interact with this data set and query using natural language and GUI. But you can do more advanced descriptive analytics using this tool too. So next I enter what is the churn rate by card type. And the output displays the churn rate by card type. It identifies Platinum as having the highest churn rate there. Similarly, I can identify churn rate by level of education. And it displays churn rate by level of education. In addition, it identifies that doctorate candidates, people who have a doctorate have the highest level of churn. But what I really want to do with this data set is to do predictive analytics on the target churn. So I set the target to churn. It immediately identifies total transaction count as the strongest predictive feature with the highest signal strength, and average open to buy with the weakest signal in that data set. And it also says the data set is not balanced and recommends balancing the data set. In addition, it says that you should build a predictive model to establish a baseline. What I want to showcase here is that in addition to querying the data set or doing descriptive analytics, you can also query the signal table. So I can enter something like what feature has the highest noise to indicator. It identifies average open to buy as having the noise to indicator. And if you look at the data set, it does have the highest noise to indicator, which is 194,000. And next up, what I want to do is build the predictive model. And so I enter it and I start the process. This takes some time. So the model got built, and the best model, as you can see, had an accuracy of 96.6% overall and an F1 score of 0.88. However, that was the overall accuracy, but for the churn data, the accuracy was only 82.6%. Ideally, we would like to increase this accuracy so we can deliver more precise recommendations that will increase retention. As a next step, what I would like to do is plot the interpretability chart. So you can see, it's not, I mean, the churn versus no churn scenarios are not that distinct. A lot of the data is clumped together. And the order is also different. From an individual level, total transaction count is the most important right now, but collectively as a model, the total transaction amount was the most important. Um, so as the system recommended, I will balance the data set next. Um, and you can see that the signal strength actually went up to 46.9 for total transaction count, and it was 37.1 before. And overall, it seems to be better. And we will also try to identify new hybrid features. And, and then there's 3 that are recommended. And what I will do is add these new hybrid features to the data set. And as you can see, one of those hybrid features actually ranked pretty high, which is the number of months the account has been inactive, as well as the number of times that they have called the call center. The multiplier is highly predictive. So what I will do now is build the predictive model again. And this will take a little bit of time. To save time, I built the model based on the changes to the data set, and I also tuned the model. Uh, the initial model built actually resulted in somewhat higher F1 score. It went from 0.88 to 0.927, and the churn accuracy went from 82.6 to 90.2. So the churn accuracy error rate has reduced more than 40%. Um, right? So 82.6 was the previous churn accuracy before balancing the data set and adding new hybrid features. Once I tuned the model, what happened was uh, the churn accuracy went to 92.4%. So it even went got more accurate, and the average F1 score for this was 9.939. So it was much better. And as you can see from the predictors, it's the blue dots and the red dots are a little bit more clearly separated, and the order, like at least at the first, at the highest level, total transaction count is the most important uh, predictive feature. As you can see, the system makes it very easy to perform descriptive analytics and to improve predictive analytics accuracy. For this particular data set, the system would typically recommend additional steps, but we've cut them down for demo purposes. Once you have a more accurate model, you can now create more precise, personalized recommendations. So in the first case, the customer is predicted to churn, but total transaction amount is not the problem. But the other uh, uh, features, such as total transaction count, total relationship count, and the transaction change between Q4 and Q1 are problems. So if you're making recommendations, you will not make recommendations related to the total transaction amount, but you would make recommendations related to the other three features: the total transaction count, relationship count, and the Q4 to Q1 transaction count change. As for the second case, the total transaction amount is the problem, but the most important issue is the total revolving balance, but you might not be able to do anything about it. But you might investigate why total transaction amount has gone down, as well as why there has been the card has been inactive for many months in the past 12 months, as well as the contact center has been contacted a number of times. So as you can see, you can very much go from building more accurate predictive analytics to making personalized, targeted recommendations, which improve the overall performance. Thank you for listening. Have a great day.